Production for the DSM-3000 is an interesting process that occurs in two parallel paths: the gyroscope itself and the electronic base. In the assembly of the gyroscope, there are two roles: the flywheel initial ring assembler and the final ring assembler. At the same time, the electronic base is assembled in a parallel path with three roles: the electronic assembly, motor assembly, and the base assembly. The electronics assembler takes the incoming printed circuit boards and attaches the necessary components, the resistors and IR sensors. After electronics assembly, the motor assembler attaches the motor and motor housing to the top of the base and the printed circuit board. Finally, the base assembler finishes the final assembly by attaching the remaining support posts to connect the top and the bottom of the base. The DSM-3000 gyroscope is controlled and powered by a printed circuit board, also known as PCB, incorporated into its base. A printed circuit board is simply a thin board, usually fiberglass, on which electronic components are mounted. The board is printed with a thin layer of metal traces to provide connections between the components. The DSM-3000 PCB has four quadrants: signal, thermal, regulator, and drive. The first three quadrants, signal, thermal, and regulator, provide information to the microprocessor, which in turn provides the necessary operating instructions to the drive. A microprocessor is simply a chip that can process programs, remember information, and perform calculations. The role of each of the quadrants is as follows. The thermal module controls the heat produced by the power source, as well as the heat generated by the motor itself, enabling the microprocessor to protect the components from excessive heat. If the voltage regulator gets too hot, the thermal quadrant will shut off the signal to the microprocessor, thereby shutting down the motor. The signal quadrant ensures the signal coming out of the microprocessor is correct to control the motor speed and the LED lights. The regulator quadrant determines the correct voltage input into the microprocessor to effectively power the motor and set the flywheel speed. The drive quadrant translates the power signal from the microprocessor to the motor to tell the motor to run.